The Restless Clock is about a struggle in the history of biology between two competing models of living things and therefore of life science. According to one model, living things are designed machines like clocks and can therefore be understood in terms of moving parts, but they are essentially passive. They've been designed to function in a certain way, and they function in that way. According to the competing model, living things are machines, but they are self-making, self-transforming machines, not designed, but continually self-making and self-transforming. And I took the title of the book, The Restless Clock, from a passage by the 17th to early 18th century German philosopher Leibniz, who is known for having been an inventor of calculus, but who also developed the notion of living things as organisms. He used the word organism, by which he meant self-organizing machines. And he described organisms or self-organizing machines as being like restless clockwork. So the Restless Clock is about the struggle between these two traditions in the history of biology. It might surprise you, actually, to know that people have been comparing living things to machines for a lot longer than most people think, really since the 17th century. The French philosopher Descartes, who is famous for having said, "I think, therefore I am," but he also developed the idea that everything in nature, including living bodies, is just machinery and can be understood in the way that a clockmaker understands a clock. And he had all sorts of machines to draw on. There were no computers, but there were automata, self-moving figures of people and animals that could do quite extraordinary things. They could play musical instruments, they could draw pictures, they could write messages, and also enact whole scenes from Greek mythology. That was very popular. They could engage with human spectators and respond, for example, by spraying them with water or spraying them with puffs of flour or coal dust in the face, playful sorts of machines. And Descartes actually lived for a time in Saint-Germain-en-Laye, near the French royal palace. In the gardens of the royal palace were grottos full of these automata, hydraulic automata, that enacted, for example, Perseus and Andromeda, the story from Greek mythology, or different stories. And he mentions those machines in support of his idea that living creatures might be machinery. He says, if artificial machines can do these extraordinary things, then think how much more complicated natural machines might be. And so it was very important to his thinking to have the existence of these lifelike machines around him to refer to. Well, you might think it would be offensive to the Catholic Church to say that living things are machinery, but in fact, it really depends what kind of machinery you meant, because the idea that living things were like clockwork, rational machines like clockwork, actually developed in close connection with a theological idea, and that was the argument from design. The idea that, so this originated in the 17th century, this theological tradition, and the idea was that you could find proof of the existence of a rational God in the rational design of nature, God's artifact. And so to say that living things were rational designed machines went quite comfortably along with that theology. On the other hand, to suggest, as some people did, that living things were self-making, self-constituting, self-organizing, self-transforming machines, that was much more problematic. That was theologically a much more problematic idea. Well, the idea of self-making machines or self-transforming machines, it sounds like it might be a 20th to 21st century idea, but in fact, that was also a 17th century idea originally. The German philosopher Leibniz, 17th to early 18th century philosopher, who is best known for having invented calculus. He and Isaac Newton both invented calculus, and then they had a priority dispute over which one did it first, but in fact they're accepted to have done it in parallel. But anyway, Leibniz also developed the idea of living things as organisms, that is to say, machines, living machines. And what he said was, in fact, that living machines, unlike artificial machines, are machines within machines within machines, all the way down to infinity. Every subpart is another machine. And all of those subparts, all those sub-machines within the machine, he said, were continually transforming themselves. So Leibniz developed the idea of living organisms as self-shaping, self-organizing machines in the 17th century and early 18th century. And then another person who was very important in that regard was the French naturalist Lamarck, who is the first person to have come up with a theory of what we now call evolution, even though he didn't call it evolution, but it was a theory of the transformation of living forms. And Lamarck also, by the way, coined the word biology. He was the first to come up with a name for the science of life. In a sense, he was the inventor of biology as the science of life and the inventor of evolution, the theory of evolution in the late 18th, early 19th century. And Lamarck described living beings as continually self-shaping, self-making, self-transforming machines as well. Lamarck has been represented as sort of a crackpot or just absurdly wrong. But in fact, he really wasn't. It's really unfair. He has been represented unfairly by historians. He did say, what most people know about him is that he said that giraffes stretch their necks to reach the high up leaves in the trees, and their necks get a tiny bit longer, and then they can pass on a slightly longer neck to their offspring. And in fact, he did say that. He did believe that organisms transform themselves through their behaviors and their habits and their acts of will. But it really wasn't a crazy thing to say. In fact, I mean, Lamarck really came up with the first complete sort of systematic theory of evolution, of the transformation of living forms. And then he was discredited around the turn of the 19th to the 20th century. He was quite radically discredited in biology. And I think part of the reason for that is that according to his theory of evolution, living things were the agents of their own creation. And that sort of threatened God's monopoly on creation. So that made Lamarck's theory rather dangerous. And I think that has to do with why he's been so radically discredited. Around the turn of the 20th century, people began to represent Lamarck as not just wrong, but really beyond the pale of legitimate science, and especially Darwinists who were eager to establish Darwinism as an acceptable theory for the 20th century. They began to try and eradicate any trace of Lamarckism from Darwin's theory. But in fact, that was really a misrepresentation. Darwin himself was very much influenced by Lamarck. And also by his own grandfather, Erasmus Darwin, who had also described living organisms as self-transforming. Erasmus Darwin did not develop a systematic theory the way Lamarck did, but he did have a sort of similar idea. And Charles Darwin was influenced by his own grandfather's work, but especially by Lamarck. And from Lamarck, he took the idea of a transformation of living forms, just that idea in itself. But then he also took the idea that later came to be known as the inheritance of acquired characteristics. That is, a living organism, by behaving in certain ways, can transform its body, like the example of the giraffe stretching its neck to reach high up leaves. And those changes will be inherited by its offspring. Darwin called that use and disuse. By using a part or an organ a lot, you strengthen it and it becomes bigger and stronger, and your offspring inherit a bigger and stronger, whatever it is, wing or leg. And disuse is the converse. So for example, moles, because they don't need to use their eyes when they're burrowing underground, their eyes have gotten weaker and weaker until the mole becomes blind. Darwin believed in the heritable effects of use and disuse until the end of his life. It remained in his theory through every revision, through every successive edition of The Origin of Species. So he was very much a Lamarckian in certain important senses. He disagreed with Lamarck on some matters, but in certain matters he was very much a Lamarckian. We all learned in high school biology and in college that Lamarck was beyond the pale of legitimate science and really antithetical to Darwin. Lamarck's theory was antithetical to Darwin's theory. And I think this has to do with the discrediting of Lamarck around the turn of the 19th to 20th centuries. But you have to imagine at the time that Lamarck, first of all, his idea that living organisms shaped themselves and created and transformed themselves threatened God's monopoly on creation. And you also have to imagine that during Lamarck's life and following it, this was the period of the French Revolution and just following the French Revolution. And that context also made Lamarck seem like a very dangerous kind of Frenchman, a materialist, an atheistic, king-slaying revolutionary kind of a Frenchman. And so that odor surrounded Lamarck's theory going into the 19th century. And then you also have to think about the context in which the reinterpretation of Darwinism was taking place. This is in the German modern research universities. Our modern research universities actually originated in Germany. That model of a scientific research university originated in Germany in the later 19th and turn of the 20th century. And in those universities, there was a kind of a limited partnership arrangement between the science and theology faculties, according to which the science faculties would offer minute descriptions of the passive mechanisms of nature, and they would leave all questions of purpose and agency and meaning, those larger questions, to the theology faculties. And one German biologist in particular, a man named August Weismann, was very, very important in reinterpreting Darwinism so as to eradicate any whiff of Lamarckism and any suggestion that organisms could have agency, by which I mean could actively shape themselves, could have agency in their own evolutionary destiny. Weismann reinterpreted Darwinism in order to eradicate any trace of that idea, and I think it really had a great deal to do with the politics of that moment, in which it was important to separate scientific questions from questions of agency and purpose and meaning. So when the German biologist, turn of the 19th to 20th centuries, German biologist August Weismann reinterpreted Darwinism to eradicate Lamarckism, any trace of the idea that organisms have agency in their own evolutionary destiny, can shape their own transformations. It meant that he really made Lamarck look radically wrong, beyond the pale of legitimate science. And he also had some collateral victims, namely several generations of mice, laboratory mice. So Weismann is not really a household name at this point, except perhaps among evolutionary biologists. But Weismann's mice continue to be quite famous. You might know the story of Weismann's mice. So let me tell you the story, in case you don't know it. Weismann, he was a biologist and not a farmer's wife, and I don't believe he used a carving knife, but he is famous for having cut the tails off several generations of mice in order to show that their offspring had perfectly normal length tails. And this he offered as a definitive refutation of Lamarck's theory. And it continues to be printed in biology textbooks and on websites. It appears on websites as a refutation of Lamarck. Of course, it actually had no bearing on Lamarck's theory, because Lamarck's idea, as I've mentioned, was that living organisms transform themselves by their habits, their actions, their acts of will, their behaviors. Now, having your tail cut off by somebody is not exactly an act of will or a behavior or a habit. And Weismann actually himself acknowledged quietly that this really didn't refute Lamarck's theory, but nevertheless, it has radically discredited Lamarck's theory, and it continues to appear, as I say, in textbooks as a refutation of Lamarck. Weismann has actually had a huge effect on Darwinism, even up until the present day. Today's neo-Darwinists, people such as Richard Dawkins and Daniel Dennett, are Weismannians. In fact, Dawkins has described himself as an extreme neo-Weismannian, in the sense that they assume that Lamarckism is breaking the rules, that you cannot ascribe any sort of agency to organisms in transforming themselves and shaping their own evolution. And even outside the field of evolutionary biology, in fields like cognitive science and artificial intelligence, that Weismannian idea is still very important. So, for example, a major example of this is the cognitive scientist Steven Pinker, who describes mind as reducible to mindless, he says, armies of idiots, by which he means many, many, many mindless subroutines, he calls them, in the brain. And so, in other words, he also is committed to the idea that living things, including human beings, including their mental processes, are essentially passive, mindless, mechanical processes. And that idea that mind reduces to mindless mechanisms, and that living phenomena all reduce to passive machinery. That idea is very important in the new atheism movement, which includes people like Richard Dawkins and also the late Christopher Hitchens. And so the new atheists have taken on board that Weismannian idea that living beings must be essentially passive. What I find really ironic about this is that I don't think any of these thinkers and writers realize, or at least they don't acknowledge, that this argument that they are using against creationism actually originated as part of a theological program, the argument from design. So in the words of the song, I think they don't know much about history. And some historical awareness reveals that not only that irony, that this argument that the new atheists use against creationism was originally a theological argument, the argument from design, but also a basic conceptual problem. I think, the engineering model of living things does imply an engineer. And if you want to get rid of the divine engineer, then you need to naturalize the agency involved in creation. That is, you need to consider ways in which living nature can be the agent of its own creation, can create and transform itself. Well, after Weismann's experiments with his mice, Lamarckism did not disappear. And the idea, more generally, the idea of living things as agents of their own creation and transformation did not disappear, but it did become sort of officially disallowed in Darwinist theory. It became against the rules, so that biologists through the 20th century and into the 21st century have accused one another of Lamarckism, or of ascribing agency to organisms, assuming that that's breaking the rules. But what I find especially fascinating, though, is that just in the last 10 or 15 years, Lamarckism has sort of been making a comeback, really coming back into mainstream biology, because biologists have become interested in studying various ways in which, in fact, changes undergone by an individual organism in the course of its lifetime can be inherited. So, for example, the currently very hot field of epigenetics, subfield of epigenetics in biology, is devoted to studying all of the factors outside the DNA that shape the way an organism is formed. And many of those factors can, in fact, change in the course of an individual lifetime in ways that are inherited. So in that sense, that's a Lamarckian phenomenon that is now being studied in mainstream biology. Stephen Jay Gould was my undergraduate honors thesis advisor, and he did have a very big influence on me. Well, for one thing, he was an absolutely riveting lecturer, a very brilliant lecturer, and he was a very scary, but at the same time very excellent honors thesis advisor. I had to screw up all my courage to go see him because he could be extremely grouchy. But at the same time, he was very conscientious. He read everything that I gave him, and he spent hours talking to me about it. And now he was very much against the design or engineering model of living organisms. he famously got into a tussle with Daniel Dennett and Richard Dawkins about this in the New York Review of Books in the summer of 1997. They had fireworks in the letters section of the New York Review of Books about this question. Gould, though, was against the engineering or design model of living organisms, not because he thought that organisms could shape themselves heritably. He was as anti-Lamarckian as his opponents in this debate. So it wasn't for that reason. But still, he rejected the Daniel Dennett's engineering model because he said it was essentially the creationist model, just without the creator. But it assumed that every single part or feature of a living organism had a rational purpose. So in that sense, it was essentially the creationist model. And Gould himself didn't believe that. He believed that many features of current features of living organisms are the way they are, not for any rational reason, but just by accident, because nature is full of contingencies and messiness and accidents and strange confluences of factors. And so you can't assume that everything has a rational purpose. And I think that Gould would be against the new atheist movement for the same reason that he was against the neo-Darwinists model back in the 1990s. That is, it's an overly rationalist model. It assumes that there's a rational reason for every part or feature of a natural phenomenon, including a living being. And he didn't believe that was true. He thought nature was full of mess and accident and contingency. Well, many areas of science today draw on lifelike machines in order to try and understand living things, especially in artificial intelligence and cognitive science. But this is a tradition that goes back to the 17th century. And it's interesting to me to see the similarities between the way people looked at lifelike machines and drew scientific conclusions and philosophical conclusions in the 17th century and the way they continue to do that today. So when I first started writing The Restless Clock, I was teaching at MIT, and at that time, Rodney Brooks was the director of the Artificial Intelligence Laboratory there, and he was working on Cog, a robot named Cog. And I went to visit Cog. I met Cog. Cog was a robot that could respond to light and sound and motion, and it was quite an eerie feeling to walk into the lab, and Cog looked over at me and followed me as I walked across the room, and if I would clap my hands, Cog would turn toward me. And it reminded me of machines that I had seen when I was doing research for The Restless Clock in Switzerland. I saw some 18th century machines that gave me a similar feeling. One of them was a harpsichordist, a young lady who would play the harpsichord. Her eyes would follow her fingers as she played, and she breathed. Her chest would heave as she played, and she also gave that almost eerie feeling of lifelikeness. And I think that I guess my point is that the cutting edge questions that we're asking in science today about when we try to design lifelike machines, we try to understand what mind and intelligence are, we try to understand evolution and inheritance, have a long history. And in that long 300-year history, there's a question that remains hotly debated, and that is the question of whether living organisms have agency in shaping themselves and shaping their evolutionary destiny. And you can't understand the stakes of that question and the argument surrounding it in science today without knowing about its very complicated and very fascinating history.